Hello, good day everybody, good evening. So I'm Sharad Bujani, I'm from Oracle India, and today we will be discussing about information and data and the relevance of both these terms to our businesses. So if there is any problem in the audio or anything, do alert me. The admin is on the line, so I would request the admin to alert me. So we'll go a set of slides here. So I have divided this webinar into two logical sections basically. So to start with, we will look at the information system in general, basically the evolution of information system. Where did we start with, where all the story started with, and where do we stand now, and probably what could be our future with respect to information systems. So the agenda is something like this. So first we will look at how and why the concept of data warehousing came into practice. So with this, you'll be able to appreciate the technology framework of the key terms and concepts in the field of data warehousing. So these are the terms you would actually get to listen if you talk to anybody who is in this field. Then we will briefly go over the main architecture, the high level architecture of our information system data warehouse enterprise system. Then we will look at what's the fundamental difference between an operational data store, that is our transactional databases, and the data warehouse. So at the end of the first phase, we will also look at what are the key challenges and opportunities in the field of data warehousing. So the second part, I have another agenda for the second part, which is going to be today, and that will revolve around the concepts of data warehousing hand in hand with the big data. So let's get started with the first first phase of the session. So the transition from relational storage to the concepts of data warehousing systems started way back in 1980s. So in fact, the term dimension facts, which we'll get familiar with in a couple of slides, were developed way back in 1960s. So people in the industry started realizing that there's a treasure of information stored in transactional database, and they also realized the need to access this valuable information in the quickest possible time. The intention was to have a system or set of concepts to provide an architectural framework for this transactional data from operational data stored to flow into the decision support environment. In the absence of such a system, let's assume there is an organization, it is having transactional data, but there is no framework as to have a decision support system at all. So in absence of such a system, if we imagine what could happen, we will have multiple decision support system in each department locally, because invariably we will need it, and these departments will be operating in vacuum. So they will have the same kind of data, they will have the same products that they are selling about, analyzing about, but it will be in a disconnected mode. So typically, way back, the management would go back and ask their MIS, management information system team, to give a report on sale of products, or what is the profits we made in a quarter or in a financial year ABC, and it would actually take weeks, or even more than a couple of weeks to get such answers. So people soon realized that our business databases were stored for transactions and for tuned for transactional processing and not for reporting. So that was that is the basic fact, that the time consumed or the reliability of big queries running for lengthy periods was this. Our database systems were not designed with keeping in mind reporting as the requirement. It was the transaction as the requirement. So there are two names that come into picture when we talk about data warehousing. Bill Inmon. So Bill Inmon is actually considered by many as the father of data warehousing. He is the first to begin discussion and giving classes around his principles of data warehousing, and he actually coined the word data warehouse sometime way back in 1970s. And another prominent name which I can't miss and I'll recollect is Ralph Kimball. So he is widely regarded as one of the original architects of data warehousing. And both Bill Inman and Ralph Kimball have contributed a lot to this field of data warehousing, and they were the forefathers who brought in a principle, a framework around which people could actually think. They put people on track, and they started evolving these concepts. So while Bill Inman came up with a book titled Building a Data Warehouse, it provided a robust theoretical background for the concepts surrounding this area. And it was Ralph Kimball who came up with a book titled The Data Warehouse Toolkit, which was first published in somewhere 1996, that gave us well-defined framework of how to go about implementing the system and make it work. If it was kind of an OLAP style of data modeling and data analysis. So this was kind of the Bible for people who are studying or who just entered the data warehouse industry. As I remember as a student, this was our Bible to refer. So now with this brief introduction of where we started, let's look at two definitions of data warehousing. So Inmon defined the data warehouse as a data warehouse is a subject-oriented, integrated, non-volatile, and time-variant collection of data in support of management decision. So I would like to draw your attention to a few facts here. So the data warehouse is subject-oriented and it is integrated. So we have various subject areas in an organization. It's the same business, but we have various departments with various subject area. So for one department, product could be the center of focus. For another department, inventory could be the center focus. For another department, sales of those products could be the focus area. So it's all subject oriented. It's integrated. So each department, when it refers to as a particular item, it's integrated across. So we will see how do we achieve this integration, the data integration, and it is non-volatile. The data does not change once you load into a data warehouse, and it is time variant. That is, the relevance of the data stays as is across time. So this was the basic definition. So in effect, in simple words, it is a database built and designed for the purpose of analysis. Then we can look at a much refined version of the same definition, which Oracle keeps as the definition of data warehouse. It's an enterprise structural repository of subject-oriented, time-variant historical data used for information retrieval, decision support. The data warehouse stores atomic and summary data. Here you see the refinement that's happening in terms of the basic terms and approach. So this will be more clear as we go through the slides here. Moving on to the next slide. So in this slide, I'm trying to capture the basic terms that are used in this area. So there's a facts, dimension, data mart, conform dimensions. So what are facts? Facts holds the measure, the quantitative, the data which can be quantified in a business. So it's an event that's happening in a marketplace. To give you an example, sale of any product. So that very transaction, sale of a product, is a fact. So the database table that stores this data is a fact table. So we got introduced to two terms here, a fact table and a fact. So facts are stored at the most granular level, and then they are aggregated at higher level. So a sale of a product, so this is a very most granular transaction at which I am defining my fact table. So that's the fact. But then you can aggregate it. So when you're in a data warehouse environment, that is for reporting purposes, you'll be looking at the same data but at a more aggregated level. Like for example, sale of product A for quarter, so and so, for a particular quarter, for a particular year. So this is the same data aggregated at a different level. So what are dimensions? So dimensions are descriptive attributes related to the data stored in a fact table. So when I say a sale of a product is a fact and it is stored in the fact table, so the details about what that product is, what is the name of the product, what's the category, what's the make, what's the model, what's the person or the company who is selling the product. So these are the various dimensions. So I will show you a quick sample of a star schema down the line. So here we are talking about facts, dimensions, and example of a dimension would be the basic dimensions that we have in most of our data marts are time dimensions, demographic dimensions, customer dimensions, product dimensions, and so forth. So these are some of the common dimensions that you would come across. Moving over to what's a data mart. Data mart is a subject oriented, or they are highly subject oriented, and they contain facts and dimension that belong to a particular subject area. Let's imagine a data mart as a miniature data warehouse for a department. So a department would have its own data mart, but this data mart would be a part of the enterprise data warehouse. So a data mart can be less expensive actually when it comes to implementing a data warehouse environment. A bottom-up approach where we actually implement various data marts across departments and integrate them would be less expensive, and it would be easy to realize the business relevance for these data marts. So that's a data mart. Now coming to what are conformed dimensions. So conformed dimensions are the common data access points across data marts that reflect the same thing. So the integration of data marts, when, as I said, each department would have its own data mart. So that when it comes to integrating this data marts, the integration would happen around the conformed dimensions. So if the data warehouse is created around conformed dimensions, it will be best suited for integrating at an enterprise level. So this is the basis for the bus architecture. So we call it as a bus architecture. Where we have common dimensions. To give an example, a conformed dimension is a time, or it's a product. So when we are talking about sale of a product, we are also talking about the time dimension there. And when the inventory is looking at it, what is the profit made around this time of the year. So if the time dimension is not common in the data marts which talk about sale of a product, or procurement of a product, or marketing of a product, we will not be able to tie the context together if the time dimension is not common across these data marts. So hope I'm bringing in this concept of conformed dimensions, because this is the center core area around which we will be able to form an enterprise data warehouse in the existence of various data marts across departments. So with the introduction of some terms and concepts, let's move and see what's the architecture. How does an architecture of a data warehouse system looks like from a high level. So here we see, moving from left to right, first we have the source systems. So source systems can be operational database, legacy systems, our ERP, CRM, even the flat files. It could be Excel files, any system where you're storing data about your business is a source system. We are moving the data in a data warehouse environment from source system to an area called as a staging area. So staging area is where the main function of ETL happens. So when I say ETL, it stands for extraction, transformation, and loading. So data is extracted from the source systems to the staging area. We will have business logic and transformation logics defined here in the staging area, by using which the data which is extracted from the source system will be transformed in the way the business needs it to be transformed, and they will be loaded into the presentation area. So when I say presentation area, these are typically our data marts, what we spoke about just a while ago. So these are summarized data which are subject oriented, which are specific to certain departments, and we load them to data marts. So this is the presentation area. So the presentation area in effect comprises of our enterprise data warehouse. So the users do not have direct access to the presentation area as such. We have other tools through which they will be querying our data marts, which store the summarized data. So the data warehouse uses metadata repository which integrates all its components. So the metadata stores definition of the source data, the data models of the target databases, and also the transformation logic that I spoke about. So the metadata repository interacts with all these three layers and ties them together. So giving a very high level explanation about a data warehouse, let's move over and look at what's the fundamental difference between a transactional processing system, which is an OLTP database, and the data warehouse. So a transactional system is designed and optimized for day-to-day transactions. These are systems where you're capturing sale of product, or it's a customer calling a call center, it's a call being made, or it's a promotion that's been sent out to the market. So these are day-to-day transactions. So the database, the system, is designed for day-to-day transactions, whereas the data warehouse is designed for analysis. There is no capturing of data happening, but there is analysis of data that's already been captured, which is happening. So here we are looking at historical data. And what's the kind of data that's stored in transactional processing system? We store detailed data in OLTP systems. So when I say detailed data, we are talking about the detail of a transaction that's happening, the detail of a product, as much as detail as possible. We are trying to capture that and storing it in one row. So in a data warehouse system, that's not the case. We are storing summarized data. We are actually denormalizing the data as much as possible in a data warehouse environment. And in OLTP system, the data and the transactions are dynamic. That is, there are inserts happening, there are updates, the rows are being updated. But whereas in a data warehouse, once loaded, the data is not going to change. So we are going to transform the data the way we want, and then we are going to load the data. So there is no updates happening in a database system. And the the kind of transaction that happens in a OLTP system is repetitive. So it's the same kind of insert, or it's the same kind of update operation that happens on this database. Whereas in a data warehouse system, the reporting that happens are ad hoc in nature. So, the requirement for a particular kind of data or a set of data can change, as far as the business need is concerned, because we are supporting decision supporting systems using data warehouses. So the reporting requirements could be ad hoc. It can change day on day. And the OLTP systems are more application oriented. So if you imagine an OLTP system, it is used for capturing data. So it is mainly designed as per the application which is capturing the data. So it is designed around that principle, whereas the data warehouse system is not worried about the application as such, but it is subject oriented. So from the definition of a data warehouse, we know that it is more of a subject oriented in nature. So with this, we can see a striking difference between the OLTP system and the data warehouse system. So both are storing data of the same business, same product, and same transactions that have happened in the marketplace, but the nature of the storage, the approach is entirely different. So moving over to what are the challenges in this field. So we saw what are fact tables, what are the basic terms and concepts, the architecture. But what is the challenge in such a system where we are dealing with such huge amount of data? Today, the biggest challenge in this field of data warehousing is changing business requirements. So as you know, the business requirement can actually change with the speed of our thought. But changing the IT infrastructure that can support such change with that kind of a speed is almost next to impossible. So the biggest challenge is the change in business needs. And another biggest challenge in today's world with the introduction of social media and various channels with which we can market our data and actually sell our data is dealing with unstructured data. So this is another aspect which we cannot afford to forget in today's industry. So this is the continuous flow of data from social media, system generated data, data captured by various sensors. So if an organization wants to have a competitive edge and wants to cater to the needs of their customers, today's needs, so this unstructured data has to be captured and brought into our information system. So these are the two biggest challenges when we talk to any people who are deal in and out with data warehousing systems and architects who are in this field. These will stand out at the top two, probably top five challenges for them. So these are the two challenges. Looking at this, now we will see how the industry has evolved to deal with this challenge and how the challenge has been brought out as an opportunity. So let's move on to big data. So at this juncture, we are stepping into the second phase of the presentation, where we will see what's data warehousing with big data. Then we will see what's we have already seen data warehousing. So we will look at what big data is about when it comes to the concept of data warehousing. Then we will get familiar with the big data information architecture, and then we will also look at what is the kind of data modeling that undergoes dealing with structured data and unstructured data. We will also look at some of the solutions provided by Oracle in terms of hardware and software solutions to deal with big data. And finally, we will see how all this has changed the way we make our business. So revisiting the definition again in very simple terms, a data warehouse is a database built for the purpose of analysis. So in today's world, data warehousing are the backbone for IT infrastructure, which enables both strategic decision making and agile reporting to the new market trends and challenges. So that's undisputed. So currently, data warehousing is undergoing a major transformation. The benefits of data warehousing are currently being realized by most of the organizations in one or the other way. So that's also not disputed at all. So the best practice for a data warehouse and a well-established strategy and technology that can support structured and unstructured data. So the organizations seeking competitive advantage are now expanding their data warehouse systems to include this big data into their analytical framework. So currently, there is a lot of hype about the big data. So what's the characteristics of a big data? So the term big data essentially refers to a large and complex collection of data sets which cannot be easily managed and processed by our traditional methods and tools. So these are data which are coming our way in high volume, high velocity, and in high variety. So these are the basic characteristics of big data. So traditional enterprise data and machine generated data, data generated by sensors, the data that's available in social media, they can all be termed as big data. So literally any data that is there out there in the industry, out there in the media, can be termed as big data. Big data and data warehouse. So from what all we have seen till now in all these slides, big data and data warehouse basically share the same goal. So it is to derive business value through analysis of data. However, big data and data warehouse differ in the scope of their data. So they differ in what kind of data they are dealing with. So traditionally, the enterprise data has various data sources, but it is mostly from structured to semi-structured data. However, with the recent time, organizations have realized that we have increasing amount of data in the digital space which is not captured in our operational systems at all. So big data mostly deals with this unstructured data. So a big data platform acquires this new sources of data, this unstructured data, and allows the enterprises to analyze and extract business value from these immense data sets. So in a way, big data is evolution of the basic data warehousing concepts, if you see. So big data may be using new technologies to handle this unstructured data, and bringing out potential business benefits which are unparalleled. However, in essence, big data requires an architecture that acquires data from multiple sources, which is the same done in the data warehouse. It needs to organize and store this data in a suitable format. Again, that's what we do in our staging areas. And then there are some an exact same these are the same exact principles on which data warehouses were designed, and then all this data in this framework is presented into analysis. So we can see the similarity and the difference between these two parallel concepts that we are talking about. So with this, let's move on and see what is the relevance or significance of this unstructured data. So a survey was made among people who are in this industry who deal with this kind of a data day in and day out. So when they were asked, what is the amount of unstructured data that's going to change in the next 3 years? People in the industry, majority, more than half, 50–60% of them actually said that the unstructured data in their business is significantly going to change. So majority, when we can see, it was the response was from significant to moderately. So this comprises a majority of the people in the industry who think that the amount of unstructured data is going to grow immensely. Now now we know that it's going to grow. What's the importance of this unstructured data to their business? So this was another key question that was asked. So again, we see that 30% of them felt that it was important. It was important to their business, and 39% of them thought it was very important for this business. So this gives us a window of opportunity for tapping big data, and the traditional systems that are there are going to stay, but we need some system through which we can accommodate this unstructured data and make derive business value out of it. So we need two approaches here because we are dealing with two vast type of structured type of data here. So we need two approaches, architectural approaches, to deal with such data. So the first model here, which is at the top, represents the traditional information architecture. The model at the bottom represents the big data information architecture. Essentially, organizations will have to look at a new approach to accommodate the big data as an extension of their existing data warehouse architecture. And the data warehouse built upon the relational database technology will continue to be our primary analytical engine, that is the database for storing the company's core data. The data warehouse will be augmented with a big data system, which will be the repository for this new unstructured data that is coming in volumes. And then data will have to flow between the big data system and the data warehouse to create a unified platform for analytics. So this is going to be the way industry should evolve and organizations should evolve. We already have strategies, we already have principles which are working models in today's business. They're already making use of both these approaches to harness the data and make business value out of it. So this was the high level description of how the two data are going to be accommodated in our information system. Now moving over to the technicalities of these two systems. So first I'm going to show you how data is stored in our traditional data warehouse systems. So when I spoke about dimensional modeling, this is what I was aiming at. So this is a simple star schema. So this is widely used approach for logical data modeling in a data warehouse. The logical model can be easily translated into a physical model, that is, we can build fact tables and dimension tables out of this diagram that we see. So a star schema is a simple form of a data mart schema. So it represents a star because it has a fact table which is at the center, and it has various dimensions forming the star points. So if you see sale of a product, which is a fact, I'm storing it in the fact table. So typically a fact table will store all the numeric attributes of this transaction. So what's the date, what's the product ID, which region, all the dates, all the date values will be stored in a fact table typically. Then I have the descriptive dimension tables, that is the date dimension, the product dimension, the store, the region, various dimensions. So this is a star schema. If you see, in an online transactional processing system, the same data is stored in tables that are highly normalized. They are normalized for transaction, as you see. Whereas this data, though there is a slight redundancy, because we go through the process of denormalizing the data in the ETL, in the staging area when we do ETL. That's because we need to support querying. We need to query high volumes of data in a data warehouse. We need to summarize the data. So that's the basic requirement of a data warehouse. So we go through a process of denormalizing the data and storing it in this kind of a fashion. But still, if you see, still there is a structure to this. Still they can be stored in a relational database system, and we have logical and physical data model for this one. So this is the simple star schema. So to contrast this, how data is stored in a big data database, a database that supports big data. So here we are looking at, this should be actually key value pair. So this is not dimension model, that's a mistake there. So this is map reduce, the process of going through the first row that is shown here is a row from a product table. So it's a sample row. So that's how a data would be stored in a relational database. So when I bring in this data into my big data information framework, I'll be reducing that as a key value pair. That is, imagine your column headers becoming your attributes and your data becoming the actual value. So each row will be map reduced into a structure where I'm storing the key and the value together. So if you imagine, the advantages of storing the data in this type of storage is it gives the agility to the way we store the data and to the way we fetch the data and we present the data. If you would have visited websites like shopping cart websites like Flipkart and Amazon, you can see that with great agility you can actually filter the data. You can filter the data based on a model, a make, price range, name of a product, or the color of a product, or the functionalities of a product. How is this possible? Do you think that it could be possible with such response time if the data is stored in a structured database? No, the data there is stored in a NoSQL form, or in a big data information framework, where we are storing the same kind of data in a key value pair. So what I'm trying to bring out here is the kind of data modeling that goes behind designing a data warehouse, and the kind of data modeling that goes behind the information framework behind a big data. So now that we have seen the two approaches, the two frameworks, and how actually the data is stored in database tables in both these approaches, let's look at what's available in the market in terms of the hardware and software support. So let's look at what Oracle has to offer in terms of the engineered systems we have. So starting with, there are three stages, as we know. There is the stage where we acquire data, then we organize our data, then we analyze our data. So these are the three main stages, if you see, both in the traditional data warehouse framework and the big data framework. So for this, Oracle Big Data Appliance is an engineered system. It's a robust platform for unstructured data, which is the best available platform in terms of in current industry capabilities for acquiring and organizing the data. So this is an engineered, when I say an engineered system, this is a system where the hardware and the software are configured to do this kind of a job, for our organizations. So this is at the organization phase, organize phase, acquire phase. Then organize and discovery phase is powered by an engineered system called Oracle Exadata. So it's a fully integrated platform for Oracle database, which is highly scalable and delivers high performance and high availability for all database workloads. So database workloads for both, structured and semi-structured. So this is well suited for a database as a database consolidation platform. And then when it when the data is acquired, organized, and stored in the form we want, we need to analyze the data. So we need a powerful system that can support that kind of reporting. So Oracle Exalytics is an engineered system with best-in-class enterprise BI platform comprising of in-memory analytics software and hardware optimized for workloads for querying. So to derive business value from big data, so it could be any technology that you would choose to implement, not just Oracle, but with any technology, hardware, and software available in the market. So to derive the business value from big data, we need the right kind of tool to capture and organize a wide variety of data, types from the data that coming out from different sources, and to be able to easily analyze them within the context of all our enterprise data. So this will be the key for success for implementing any system using any kind of a tool. So now we saw the kind of hardware and engineered platform for dealing with data. Now let's look at what are some of the software components provided by Oracle. So these are the Oracle integrated software solutions for dealing with traditional and big data. As we can see in this slide, these are Oracle integrated tools. So we have NoSQL database for that supports the acquisition of big data. Then we have data integrator for transforming the big data. Then we have various tools like Hadoop and MapReduce logic that we are going to use to reduce the structured data into massive flat files that power big data platforms. So this is just to give you an understanding of the kind of tools and capabilities that are available that makes everything that we spoke about in a couple of slides actually possible. So moving out to the big data appliance, because since the big data appliance is at the heart of the acquire phase of this framework, we will just spend a slide on big data appliance. So with the recent introduction of big data, Oracle became one of the first vendors to offer a complete and integrated solution to address the full spectrum of enterprise big data requirements. So remember, the big data is transactional data, machine generated data, social data from social media data. So we are dealing with various sources and various structures of data. So it is built, the big data appliance engineered system is built using industry standard Sun hardware, and it is optimized for both batch and real-time processing using Cloudera's distribution for Apache Hadoop, and it is also integrated with Oracle NoSQL database. So these components are at the core. These software and hardware components are at the heart of big data appliance. So basically the approach here stays the same. It is you evolve your current data warehouse framework to bring in data and add value to the business. So big data appliance is the answer to extract value out of this new type of data that is coming in our way. Remember, big data, the major three characteristics are it's coming in volume, it's coming in high velocity, and high variety. So to deal with all these three characteristics, we need high-end systems that can handle that kind of a workload. So now looking at where we came from, the evolution, the purpose why the industry went through a transformation, a change in where they captured the data, the way they stored the data. With the introduction of big data, so we adopted the big data as well. We also saw what are the hardware and software components that make big data a reality in today's world. So with all this, let's take some time to see how all of this has changed or evolved the way we do our business. So in this, we will see the creation of new possibilities in our business organizations. The time when where we only had database systems, we had only historical data for our analysis. So that was the phase where top level management only had data about sale of their products in the past. They had no clue about what people are talking about their products, what is the kind of feedback they are getting from their products which are being sold in the marketplace. So they had no system to capture that. But from there, in today's world, we are in a system, we have a backbone in which I'm selling a product, I know the history of my product, and I'm also looking at live data of what people are talking about our product in social media, in our feedback surveys, and in various forums. So our reporting has also gone from just ad hoc reporting to intuitive driven or insight driven predictions. So from reporting, some from just forecasts, we are also predicting on how a particular product life cycle can be molded, or how a product is going through its life cycle. So we can also do some kind of a prediction here. So from a fragmented view of our data, we are having a unified view. So not by just about how I'm selling my product, but I'm also be able to looking at how my product is being absorbed or being received in the market. So this is the kind of transformation or the possibilities that are possible with with accommodating the unstructured data in our information framework. This is best understood, as far as I know, is through an example. So let's look at this example. I'm taking the insurance industry as an example here because most of us would have some kind of an insurance in place, be it medical, car insurance, a product insurance, insuring your valuable products or anything. Let's take a look at car insurance as an example. Assuming our insurer has big data framework in place with the traditional data warehousing, this is how his business could change. So in the acquisition phase, this insurance company would go about acquiring data about my being, let's assume I am the person who has taken the car insurance and I have a car. So the company, through sensors, so possibly sensors installed in the car, they can track my driving habits, the kind of braking patterns I use in my daily drive, and the average distance I would drive on a daily basis. So in the acquire phase, they would actually acquire all this data through machine generated data. These are sensor based data. So in the organized phase, knowing my other data, so these are insurance companies whom I have been with for some time, so they know my other demographic data, my all my other data, that is and they will be able to organize that historical data with this new data. So they will be able to derive information based on the historical data and the new unstructured data that is coming in. They will be able to organize it around their business needs, and during their analysis they can analyze all this data in their information framework, and with this they can, and also with other information like what is the kind of traffic I drive in, if I'm living in Bangalore, what's the kind of traffic I'm going through, so what are the routes that I take, and what are the conditions in which I drive. So they will be able to actually predict the amount of risk or the possibilities of the risk I would get into an accident, or I'll be susceptible to an accident. So how, you may ask me how it's possible. Knowing the driving habits, they will be able to know whether I'm a safe driver or a rash driver. Knowing the make and model of the car, they could, and also the kind of traffic conditions in today, they will be able to judge the percentage of me getting into a possible incident or not. So based on that, they can actually decide to give me a insurance premium or the final bill based on the all this historical data and the new data that they have acquired in their system. So this can actually change the way they do their business, and also the way customers are treated in the industry. So with this, a person who is safe, is more less susceptible, could actually benefit from this by getting insurance premium which is less, and people who are indeed need a higher premium because of the kind of driving habits they would have, or to the situations they are exposed to, they will be landing up paying a higher premium. There is also immense amount of work that's being done in other fields, like medical care and predict and let's take the example of a patient who is going through uh, as a heart treatment. Let's take the another example of health industry. Let's assume there is a patient who has been installed with a kind of pacemaker or some kind of a medical instrument in his body to monitor his heart rate, and based on which he needs to be analyzed and given a treatment or a prescription. If there is a need like this, the patient will be exposed to a continuous data needs to be read in real time. So let's assume there is no big data information architecture in place. The patient actually needs to go to a hospital which has readers which will be connected to him, and he has to spend probably one day, a couple of days, to see what is the kind of heart rate and what is the kind of stress he's going through on a daily basis. That needs to be captured, and for this he needs to actually go to the hospital. Let's assume or imagine a scenario where this particular piece of instrument is implanted in him temporarily. He goes across his usual routine work, his daily life, and this data is captured real time at every other minute, and it is relayed to the server that is sitting in the hospital. So they could actually, instead of accumulating 2 days of data, they can accumulate a weeks of data or even 15 days of data. I can, and with the second visit, just one visit where he gets this instrument installed, and by the time he actually goes to his second visit, his report about his performance, his heart's performance, what needs to go on, what is the kind of medication he has to be exposed to, or what is the kind of precaution he needs to take. This report on this can already be found by the time he goes to the second visit. So what I'm trying to bring out with all this is the kind of technology that we are talking about can actually redefine various industries, how they operate, and the kind of business benefits customers will have from this. So with these two examples, I tried to make it as simple as possible to show you the complexities and also the simple benefits that we could have from the system. So to conclude, to summarize all this, so we started with the evolution of database systems, information system. Then we saw the need for a data warehouse kind of a system, the data warehouse framework. Then we saw the difference between the transactional processing systems and the data warehouse. Then we saw the evolution of data warehousing systems and concepts, and the bringing in of the big data information architecture. Then we saw the tools, the hardware and the software tools that are required to support this kind of an information architecture. Then we also saw how this kind of data, if realized in our business, can actually bring in change. So with this seminar, with this session, I hope you will be able to appreciate the kind of evolution that the information system has gone through in these couple of decades, and also the business benefits it is able to deliver. So if you have any questions at all from this one, this was a very high level discussion of various technologies which are too detailed. There are various courses actually offered by companies. I know for sure, because I come from Oracle, we have courses on every product literally I spoke about. They are detailed courses. There are seminars targeted at various audience. There are courses for implementers, there are courses for administrators, and there are courses on Exadata, there are courses on big data. So it's a huge footprint of courses and products that I'm talking about. So there's a vast amount of information that is also freely available on oracle.com. There are various webinars that are focused on this, and also available on the internet and YouTube. So the intention of the seminar was to summarize all these things and present uh, the entire evolution in a couple of slides, in order for you to able to appreciate the process, the technology that goes into this. So thanks for your time. You can email me any questions that you have. So have a good day. Thank you.
Sharath, I have enabled question and answer.
Oh,
Can you hear
great.
me?
Thanks, Vino.
Yeah, so
Yes,
let
I
us
can
wait
hear you.
for the next few minutes and see if there are any questions. And if there are any, then we will close the session. Thank you very much for the detailed presentation on big data.
Thanks, Vino.
We'll just hold by for any question and answer. Uh, you can post it on the Q&A that I have enabled now for the webinar. And also kindly ensure that you have voted for your polls which were available. So I think there are no more questions. And thank you, Sharath, for your detailed presentation. It was wonderful to have you with us at ISA. ISA looks forward to more participation from your friends and colleagues as well. But whoever is on the call today, there has been excellent participation from all the members. Kindly look out for future seminars, which is the next one is on the September 2nd. Kindly visit our website, our chapter, and then get involved in more participation. It will be very useful knowledge sharing. Thank you very much and have a very good day and good night.
Thanks a lot, Vino. Bye. Good day.
Bye.